Hello there. Hopefully you all are doing well. We're still not at school, obviously, but hopefully you're taking care of yourself. All you secondary 2 math students out there. I'm Mr. Green, for those of you that don't know me. Some of you are in my class, but I'm going to be going through some graphing today. So let me go ahead and put this up on the board and we can get started. So in the previous videos that you've watched, you've seen graphing different types of equations. And before I dive into the stuff that I want to do today, I just want to kind of review the different types of graphs that we've seen so far. Okay? So the very first thing that we looked at, which you've seen for a very long time throughout junior high, was linear graphs, right? And the equation for these was our famous y equals mx plus b, right? Where your m, this is your slope, and your b, this is your y-intercept, right? Where it crosses the y-axis, okay? And the slope was the rise over the run. So how much you go up divided by how much you go over, right? So this was our equation, y equals mx plus b for linear functions. The graphs of these functions, well, they looked like straight lines, right? They were lines like this, okay? So hopefully you've seen that a lot by the time you're reaching this point in your education. So hopefully this isn't too much of a reminder, but some of you may be refreshed on it from that first lesson. Okay, so then the second type of equation we went over together was we talked about quadratic functions. Okay? And you learned about those at the beginning of this class. Okay, so quadratics. And these were things that had a square in it. Okay? And usually the way we like to write our equation here, there were several forms that we could write our equation in, but the one that helped us graph the most was y equals, and we had x minus h squared, okay, and then plus k. This was called the vertex form of the equation of a parabola, okay? And we called it the vertex form. Oh, maybe I should add in here. Sorry. We should have a little constant in front of the square as well. Sorry, I forgot about that. The h and the k in this equation, this tells me where the vertex is, right? I just switch the sign on the h, right? If it's a minus, it will be a plus h for the vertex. And if it's a plus out here, I leave this one the same, right? I switch this one and leave this one the same. That tells me where the vertex is, okay? And this one, the a out front, tells me how wide the parabola is, right? How kind of tight or narrow. If it's negative, it tells me that it's flipped upside down, right? So the graphs of quadratics, they look like U shapes. They're like parabolas, so something like that. Okay? So there's our quadratic functions, okay? So the x is squared in this equation, right? But the y is not, okay? So let's keep going. We've talked about quadratic now. The thing we talked about in the last lesson was something new that you hadn't seen before in class. And that was circles, okay? We've been talking about circles before. We found areas circumferences, right? But now we actually talked about how you can write the equation of a circle, what the equation of a circle looks like. And we talked about that was, we have like x minus h squared plus y minus k squared, and this was equal to the radius squared, right? This was our most general equation of our circle, okay? And this h and this k in here, these told us where the center of the circle was at, right? I just switched the sign on the h and the k, so it's a little bit different than the quadratic. I switch both signs, and that will tell me where the center of my circle is at. And then this r here, this is the radius, right? So we have x minus something, that's the x coordinate of the center. This is the y coordinate of the center, equals the radius squared, okay? And what do the graphs of these look like? Well, they're circles, right? Something along those lines, okay? So, we've talked about lines, quadratics, and circles last time, right? They all have different equations, and the different parts of those equations mean different things, okay? So we're going to look at today another example of a new type of graph that maybe you haven't seen before, okay? And the name of that function is called absolute value, okay? And how we represent absolute value is we put little bars around numbers, okay? And what this means is when you see the little bars, what you do is it's really simple. If there's a negative inside of the little bars, okay, you're going to switch it to be a positive, okay? So basically the bars just mean anytime it's a negative, you flip it to positive, okay? So in this case, I had absolute value of -2, switches, it becomes +2, okay? If I do absolute value of -9, that is going to be +9. I just switch all my negatives to be positives. But then you may ask, what am I going to do with my positive numbers? Well, I'm just going to leave them the same. The idea of this absolute value function is sometimes I don't want to deal with negative numbers, and so this absolute value function just makes everything positive, okay? If it's already positive, it's just going to leave it alone, okay? And then absolute value of 3 would just still be +3, okay? So whenever you have a negative inside of the bars, it flips it to be a positive, right? The absolute value of -9 is +9. But when you have a positive inside of the absolute value, inside of those bars, it just leaves it the same, okay? The idea of this function is it just makes everything positive. It doesn't like negatives, it wants them to be positive, okay? So that's what we're doing here. We're just flipping negatives to be positives with our absolute value, okay? So that leads us to ask, well, if I were to throw an absolute value in the equation and then graph it, what would that look like? Okay? So that's what we're going to look at now, is if I had y equals the absolute value of x, what is that going to look like when I graph it out? Okay? Well, what I'm going to do, I'm going to just do a table and get some points, okay? And once you kind of know what this graph looks like, you won't have to do this every time, but I just want to show you why the graph looks the way it does, Okay, so I'm going to start by, let's plug in 1 into this equation. Okay, so when I plug in 1 for x in the equation, I get the absolute value of 1, which when I do absolute value of a positive number, it stays a positive number. And so I just get 1 there for my y. So that tells me I've got to go through the point 1, 1. I'm going to be at that point right there. My x value is 1. My y value is 1. Okay? Let's do it again. Let's figure out another x value to plug in, maybe 2. Okay? Plug in 2 for x. For my y, I get absolute value of 2. Again, I'm doing absolute value of a positive number, so it's positive 2. Okay? So that tells me x is 2, y is 2, so I go 2 over, 2 up. I'm going to be at that point right there. Okay? Let's do it again. Are we starting to see a pattern here, hopefully? It looks like for these numbers, it's just leaving them the same, right? When I do 3, absolute value of 3 is positive 3, okay? So that means I'm going to go over 3, up 3 to get my point. Okay. Well, that kind of tells me what's going on over here. I would expect if I plug in 4, I'm probably going to get positive 4, right? It seems like every time I plug in a positive number, I'm getting the same thing out, right? And that's exactly what absolute value does, right? If I plug in a positive number into absolute value, I get out the same number that I plugged in, okay? So when I plug in like 5, I should get 5 out, right? So I should be at 5, 5. When I plug in 6, I should get 6 out. I should be at 6, 6, okay? And so this is kind of what it looks like over here. And in fact, it's probably, if I connect my dots, it looks like it's a straight line. It looks like something like this, okay? Now, I should be a little careful here because I don't know what it does when I start plugging in negatives yet. Let's try over there. So maybe let's start with 0, okay? Absolute value of 0. Well, 0 is really neither positive or negative, so we just say the absolute value of 0 is still just 0, okay? It doesn't have a negative in front, so it just keeps it as 0. So I'm going to be at the point 0, 0 here. So it looks like I keep going, okay? But then what happens when I plug in negative 1? When I plug in negative 1 for x in this absolute value equation, I get absolute value of negative 1, which becomes, when I do absolute value of a negative number, I get a positive number, okay? I get positive 1. Interesting. So let's plot that point. X is negative 1, y is positive 1. So x is negative 1 right here, y is positive 1 right here. Okay? Well, that kind of broke our pattern, didn't it? It's not just a straight line. It kind of veered off right there. Okay? Let's try another negative number. When I plug in negative 2 for x, what do I get? The absolute value of negative 2 is positive 2. So at negative 2, I'm going to be at positive 2. Interesting. What does this look like? Well, if you keep doing this, if I plug in negative 3, it's going to switch that negative 3 to be a positive 3 right here. It looks like this. It's a V shape, okay? So the absolute value graph looks like a V, okay? Just going at 0, it's a V, okay? Kind of interesting. So take a moment and pause the video if you don't understand and try and figure out, how did I get this shape? What did I do here with this table? Okay, pause the video if you're stuck and make sure you understand where this graph is coming from. Okay? If you're all caught up, we can keep going. Okay? Okay, so now that we have that graph of the basic absolute value function, right? It's a V shape. So let's just sketch it. It goes over 1, up 1, over 1, up 1 on this side, so it looks like this. And then left 1, up 1, left 1, up 1, it's a V. Like this, okay? So this is the regular absolute value of x, right? So what happens when I start throwing numbers inside of the absolute value with the x, okay? Well, it's the same sort of thing as happens with your parabolas, right? When I graph x minus 2 squared plus 3, what did this do? This 2 moved me to the right 2, and then this 3 moved me up 3, okay? So the same thing is going to happen here, just instead of a U shape, it's going to be moving my V shape, okay? So this 2 right here, this moves us right. It does the opposite of what you would expect because it's right next to the x. We go right 2, and then this 3 here means I go up 3, okay? So I'm just going to go to my graph. Right 2 from 0, 0 is 1, 2, and then up 3. 1, 2, 3. So that's my new point, my new corner point of the V. And then I just sketch in the same shape. So I go over 1, up 1, over 1, up 1 on this side. It's going to look like that. And then my other way, it also just goes over 1, up 1. Over 1, up 1. So this graph in the red, this is f of x. Okay? So notice it's very similar to graphing quadratics. It's just with a v instead of a u, right? Quadratics have a square in them. Absolute values have these bars. Okay? Let's do another example and make sure we got this. Okay? So let's do absolute value of x plus 1 and then plus 1 outside. Okay? Well, this plus 1 on the inside with the x, what is it going to do? It moves the x, and since it's next to the x, it does the opposite of what we might expect, right? Normally, when I think plus, I think right, but since it's next to the x, I go left. Okay? This will be left 1. Okay? What will this be? Take a second and think. What will the plus 1 on the outside do? We go up 1. Okay? So my normal graph is a V at 0. Let me sketch that again. This is my normal absolute value graph, right? So what does g of x, this function, look like? It's just left 1. So I go to the left 1 right here, and then I go up 1. So that's my new corner point, okay? And then I just go over 1, up 1, over 1, up 1, over 1, up 1. Now this absolute value is really nice because on each side it just has a straight line, right? So it has a constant slope, unlike quadratics where it bends, right? This one just stays flat, a straight line. Okay, and then this one goes left 1, up 1, left 1, up 1. So you notice these guys overlap over there. Okay? So, what have we done? We sketched the graph of g of x, and the stuff next to the x just moves us left or right, and it does the opposite of what we would think, and then the thing on the outside moves us up and down, and it does exactly what we think it would do. Okay? Go ahead and pause the video and make sure you understand where I got this graph. Okay. Last one. We'll do one more example. Let's say I have something like this, where I have a negative in front of the absolute value. Okay? What is that going to do to my graph? Well, this still tells me, the thing with the x tells me I'm going to be to the right too, because it's opposite of what I would think. And this plus 3 tells me I'm going to be up 3. Okay? So let's go ahead and get there. Right? 2, and then up 1, 2, 3. So right there, that's where the corner point is going to happen. Okay? But then what does that negative do in front? Do you remember, if I had a negative in front of my quadratics, what did it do? Well, I still moved to the right 2, and then up 3 with this one. But instead of opening upwards, right, it actually opened down, right? When I went 1 away from the vertex, I went down 1 instead of up 1, right? When I went 1 away from the vertex this other way, I went down 1. And so we got a downwards facing parabola, okay? The same thing is true of this absolute value function, except instead of being the U shape, it's a V shape. It's just an upside down V. So instead of going over 1, up 1 like I normally do, I'm going to be going over 1, down 1, over 1, down 1, over 1, down 1. Okay? And then over 1, down 1, over 1, down 1, over 1, down 1. Okay? So this would be our graph here. Okay? So it's very similar to graphing quadratics. The same sorts of things happen. If you have a negative out front, that's just going to flip it upside down instead of being right side up. Okay? So hopefully that helps you get a handle on these absolute value functions. You'll want to go ahead and try and do the homework problems that we've made for you. Check your answers with the key, and then take the quiz to make sure that you can do things with absolute value. I hope you have a good day. Good luck.